Section 2 of Chapter 1 is a little refresher on angle relationships in similar triangles. Remember that vertical angles are formed by two intersecting lines, and they do not share a common side. So angle 2 and this angle would not be vertical angles because they share this side. But angles 1 and 2 would be vertical, and they're congruent, meaning they have equal measure. Remember that parallel lines lie on the same plane but don't intersect. So here we have lines M and N are parallel. And then we have a transversal, and that's a line that intersects two parallel lines. Some angle relationships within parallel lines in a transversal are the alternate interior angles, and those are the angles on the opposite sides of the transversal, or alternate sides of the transversal, and they're inside the parallel lines. So alternate interior are 3 and 6, and 4 and 5. And those pairs are congruent. So 4 is congruent to 5, and 3 is congruent to 6. Then we have alternate exterior angles. Again, they're on opposite sides or alternate sides of the transversal, but they're outside of the parallel lines. So we have 8 and 1, and 2 and 7. And again, those pairs are also congruent. 2 and 7 are congruent, and 1 and 8 are congruent. Then we have same side interior. That means they're on the same side of the transversal, and they're inside the parallel lines. So 4 and 6, and 3 and 5. And those pairs have a sum of 180 degrees. So if you add the measure of angle 4 and the measure of angle 6, you would get 180 degrees. And then we have corresponding angles, and those are angles that are basically in the same place with the parallel line and the transversal. So 1 and 5 are in the upper left-hand corner, 2 and 6 are in the upper right-hand corner, 8 and 4 are in the lower right-hand corner, and 7 and 3 are in the lower left-hand corner. And those are also congruent. So all of these relationships are congruent except for the same side interior. Those are supplementary. So let's apply that concept to example 1. Find the measure of each marked angle in the figure below, given that lines M and N are parallel. All right, so we have angle 5x plus 7, and we have this angle of 8x minus 22 degrees. They're same side interior, so they're going to have a sum of 180 degrees. So we have 5x plus 7 plus 8x minus 22 equals 180 degrees. So we combine our like terms. So we have 13x minus 15 equals 180. Then we're going to add the 15 over. So we get 13 equals 195. And then we're going to divide by 13. And we get 15. Now remember, the original problem said find the measure of each angle, not just solve for x. So we need to plug those in. 5 times 15 plus 7 gives us 82 degrees. And then 8 times 15 minus 22 equals 98 degrees. Quick check, do they add up to 180 degrees? They do, so we're good. Remember that the sum of the measures of the angles of any triangle is 180 degrees. So in example 2, the measures of the two angles of a triangle are 63 and 35. So we'll say this is 35, and we'll say that's 63, and they're degrees. Find the measure of the third angle, x. So we know they all have to add up to 180. So we have 35 plus 63 plus x equals 180. When we add the 35 and the 63, we get 98 plus x equals 180. Subtract the 98 over, and we get 82 degrees. And we have completed example 2. Now let's remember our different kinds of triangles. We have an acute triangle, which has all angles are less than 90 degrees. We have a right triangle, so one angle is 90 degrees and the other two are acute. Then we have an obtuse triangle, which means that we have one obtuse angle and then two acute angles. An equilateral triangle has 3 congruent sides, and it also has 3 congruent angles. An isosceles triangle has 2 congruent sides, and a scalene triangle has no sides that are congruent. Remember that congruence means same size and same shape. The corresponding angles must have the same measure, corresponding sides must be congruent if it's congruent triangles, and proportional if they're similar triangles. So let's apply that to example 3. Triangle ABC is similar to triangle TUV. Find the measures of angles U and V. Find the lengths of the unknown sides of triangle ABC. So if we have triangle ABC is congruent to similar to triangle TUV, then angle A is congruent to angle T, angle B is congruent to angle U, and angle V is congruent to angle C. Okay, so the measure of angle U is going to be equal to 96 degrees because it's congruent to angle B. The measure of angle V is going to equal 52 degrees because it's congruent to angle C. And then, let's see, side AC over, what was that, 16? Is going to be equal to, and side AC is proportional to side TV, so that would be 20, and then CB is proportional to UV, so that'd be over 8, and then we just cross multiply, so AC is going to equal 40. And then we have, so AC is 40, we'll label that. Then we have side AB. Let's move this up just a little. Side AB over 16 is going to equal 16 over 8. So then AB is going to equal 32. Because 16 over 8 is 2, and then you multiply the 16, so we get 32. And finally, example 4. 5-foot-tall Melody. So here's Melody. She casts a shadow that's 84 inches. 84 inches. And she's 5 feet tall, which is 60 inches. We're going to convert everything to the same units. How tall? She has no arms. Okay. How tall is her brother if at the same time of day his shadow is 1 foot shorter? So we'll take 12 away from the 84, so we get 72 inches, and we want to find out how tall he is. So now it's just a basic proportion. So we have 60 over 80 equals x over 72. So then when you solve for x, you get you get 54 inches, which when you divide by 12, if you want to get it into feet, when you divide by 12, you get x is approximately 4.28 feet.